welcome with a warm hand, Mitch Hashimoto.
Thank you. All right, thank you. Today I'm going to be talking, the talk title is Looking Beyond Automated Tooling in the Modern Data Center. And this is a keynote style talk, so it is, as much as I like to, I don't go as deep into anything technical. But right after this talk, I have a talk upstairs that we're going to dive into security and Vault. So if you want something really technical, come to that. But what this talk is about is something that I get asked a lot about. And I get asked, how does Hoshi Corp come up with ideas? How do we view the data center yesterday, today, tomorrow? And how does that mold sort of what direction we're heading in and how we also view other people in the industry? And this is sort of a framework that Armand's my co-founder, we came up with years ago to sort of figure out how we're going to build things and reason about things. And that's what I want to present today, because my background is an engineer. I like to believe that everything has a very understandable reason and order to it. And so I like to try to apply models to everything. And this is sort of my model and the way I look at DevOps, at tooling, at the change in data centers, and so on. So I got an introduction already. The only thing up here that's different or it's new is my Twitter handle, and you could use that to contact me if you want. I'll be here the rest of the conference, but you could use that if you can't get a hold of me or can't find me. Like I said, I founded a company called Hoshi Corp. We build a lot of things, so we have 9 separate things, and most of them are open source. And what's really unique about our portfolio of projects versus sort of others, besides actually having a portfolio rather than one project, is that they span so many different things. So in the center there's Vagrant, which I believe a lot of you have heard of Vagrant. It's the oldest thing we have. It still gets millions of downloads a month. And that's targeted sort of at developers, right? It's developers. But then completely on the other side, in addition to a tool that runs on your desktop that's targeted at developers, we have stuff like Nomad and Vault. Like Nomad is a distributed cluster manager that runs in production. And I hear sometimes that it's kind of odd for a company to have desktop developer software and then mission critical production runtime distributed systems. And so we do sort of a lot of things, and I'm not going to talk about any of these actually in detail today. Like I said, I'll talk about Vault in the next session. But what I want to talk about is looking sort of from then to now and using that knowledge in order to both design systems from my perspective, but more from a lot of your perspective, like how do you consume them? Is it something worth adopting? Is it something that's going to get replaced soon? These are the questions that you need to ask. So the questions are really, how do we get here? Why does the cloud exist? Why do the tools around the cloud exist? Why are things the way they are? If they seem broken or something, why did we end up in that state? Like I said, what things am I going to replace? What things are not going to be here for much longer? But what new problems do I have? What things don't have solutions yet or need a solution? What things are completely gone? So usually when we see paradigm shifts like VMs to containers and so on, certain problems just become non-problems. They completely disappear. At the same time, you get brand new problems. And then finally, I think the big question that if I could actually answer truthfully, I'd probably not do technology. I'd do like stocks or something. But what is next? And trying to reason about that. And the motivation is for everybody. So if you're just somebody that likes to tinker with things, something that I would categorize as a hobbyist, then the motivation is really to just be able to play with the newest things and understand why they exist. If you're a customer, if you're someone that buys things or consumes things, then you really want to understand why you should be looking at something and the cost of that. And even if it's a free thing, I'm not talking about necessarily financial cost, but the technical cost, the mental cost of adopting something, and understand if it's worth it. Because if you adopt something and it's pretty much going to be replaced or it's not the correct way to do something, that's going to affect you down the road greatly. And then as a vendor, if you're a vendor, sort of like myself, then you really want to build what I like to describe as a map of the industry so you can understand where you fit, who are your competitors, what you should be thinking about in the future. So this answers sort of all those different questions and roles. So welcome to the age of containers. Whether you like it or not, it's sort of the hottest thing that's happening right now, and everybody's talking about it. But it gets a lot of positive, for sure, as everyone knows. But then you see a lot of negative of things like, or is this the age of reinvention? Are we just doing everything, or we're doing most things over again that we've already solved? So as an example, here are tools in three categories. There's a lot more categories of things, obviously. I chose these three to show you. And here are tools that have historically been within these categories. And if you take a look at them, it's interesting because none of them they're all highly adopted, highly deployed. I'm not saying they're going away, but they're no longer the thing that is the top choice to use with the newest technology. And that seems odd. It's very odd. So, like I said, they're still widely used, but they're not the talks you see. They're not the top choice of companies. Both my experience with the open source community as well as my experience walking into enterprises for sales reasons. These are not the tools that they're looking to adopt. A lot of times, a lot of these tools are the tools they're looking to leave. And the question is why? So what is going on? You could pass off one thing as a fluke, but it's not a singular event. There's a lot of tools sort of entering this space, and there's a lot of tools even for myself that enter this space, right? Like when Docker came up, a lot of people replaced Vagrant with Docker, which I'm totally fine with, but the question is, it's more important to understand why that's happening and what the purpose is. And so it's not a singular event. It's happening across a lot of different categories. So I showed you three there. I guess a fourth one would be like development environments. So it's happening across a lot. And the people that are doing this are often regarded as smart people. Whether you think it or not, a lot of other people think these people are smart. And so it's happening. And so you could keep pushing back on it, but it's going to happen. So even if I disagree with something and I want to push back on something, I do still want to understand why that thing is happening. So to understand, the first thing I want to look at is this. This is sort of how I just break down at the highest, like kind of abstract level, what I call the app lifecycle. And this is so generic, it applies to everything, basically. It doesn't matter if it's a mobile app or a web app or an embedded system or whatever it is. Everything sort of goes through this loop of dev, test, deploy, and monitor. There's more things you could break it down into, but this generally is accepted by everybody as a high-level agreement. And the purpose of businesses today really is to be able to move through this as quickly as possible. If you produce software, which is just about everybody, whether you're an actual software company or a car company or a thermostat company, everybody's producing software. And when you're producing software, you want to move through this as quickly as possible. And I like to describe DevOps, or the goal of DevOps, is really to move through this as quickly as possible with both technical change and human process change. And when you look at this, I like to color code them based on sort of categories. So there's categories dealing with monitoring or observing. There's categories dealing with development or further enhancement of the tools. And then there's more control around deployment and making sure things run and happen in the order you want. And I'm going to get back to why this is really important. So observe, enhance, control is sort of how I break down various things that happen throughout this circle. And here's some subcategories within there. And these are all categories that have their own set of tools separately. And one of the first things I do is just assign, as tools come out, I assign them to these categories. It helps build this map of what's happening. And we'll just remember this for later. But we're going to dive right into specific examples. So let's go back in time to what I'll call the age of the virtual machine, which is 2006. You know, virtual machines have been around since the late 90s, or even further, but VMware really is the late 90s. But they really, really took off in 2006, thanks to a lot of things like EC2, mostly. And if you look at this, these are the properties of the data center in 2006. These are properties of the data center. There's no APIs. EC2 is brand new, so it doesn't count. Like, it's just this weird cutting edge thing that no one's taking seriously. So the data center at the time is really no APIs, not just for your servers, but for anything. Everything is click this, click that, request this, wait, file a ticket. That's how things work. there's very little elasticity. You don't think about the idea of auto-scaling because there's no real APIs, because it's slow. You don't consider anything elastic at this time. There's monolithic applications. Applications are big, they don't move, you treat them as pets. And then infrastructure as a service like EC2 is just very young. So, like I said, people aren't taking it seriously right now, or in 2006. And then there's problems that emerge because of these. Because of the properties that we're working with, there's certain problems that we have. The problem is keeping uniformity of servers. When you have these big giant servers that don't change and there's no elasticity, you really want to keep them uniform. You want to keep everything working properly. You don't want drift and things like that. That's directly related to scalable change management. As you make changes across these servers, you want to do it more quickly, especially as you add and remove servers. You want to be able to know the state that your servers are in. This is sort of all related here, but you want to know if things are different or if things are broken on the server itself. And we're starting to deal with sort of early service discovery in the sense that microservices aren't really a thing, generally accepted thing here. There's some service-oriented architectures, mostly in the enterprise, but we're starting to just think about, okay, we're breaking things down. There's a little bit more applications. How do we find them rather than like hard-coding IPs and things like that? And this is especially important as this elasticity grows, as we'll see. And then, so if you take the properties of the data center and then you look at the problems they have, then there's properties of software that come out. So the software around the time, if you look at all the software that's popular around 2006, majority of it is manual sort of node registration or deregistration. Think about Chef or Puppet or things like that. A lot of it's pretty manual to get that thing into a cluster. There's a lot of single master servers. You're not seeing a lot of distributed systems. Paxos is there then, but you're not seeing it anywhere. And if you think Raft is simple, I mean, it's a lot simpler than Paxos, but Raft is not something that, because Raft exists, suddenly distributed systems are possible. They're very much possible here, and yet you're not seeing them. There's a lot of caring about checking and correcting divergence. For a long time, that was sort of the mantra that Puppet and Chef ran under. You ran them as crons or as system agents, and they would correct drift, right? That was like a feature they had, and people cared about that a lot. There's a lot of agents happening, just I think pretty obvious. And then the last thing is a tidbit, but it's actually relevant for some reason. But there's a lot of Ruby around 2006, and I'll explain why that's important in a little bit. Just remember it. So in 2006, this is what you see. This is what I saw, is that the properties of the data center make constraints. You can't really work outside of those constraints because you're going to have to deploy into the data center. So that's necessarily the thing you have to work within. So then applications will always fill the full capacity of the constraint. And the best concrete example I give of that is as RAM has increased and increased in our desktop computers, applications somehow find a way to fill it without doing much more. Right? We decide that, oh, we have 8 gigs of RAM now, let's just write all our applications in JavaScript in an embedded browser and forget system level programming. And so applications will always fill the constraint. So the applications are, in this case, filling the constraints of the data center, and we're exposing problems along the edges. You then take those problems, and vendors and sort of ambitious open source people and stuff will write software to help solve those problems in a way that fits within those constraints, because they're also an application that has to run within that data center. So the architecture of that software is going to match the data centers, and they're going to solve the problems that the applications have. And I liked this because as an engineer, and also I have a degree in math, so looking at this, the first thing I thought of was that this seems pretty algebraic to me. And a very simple way to look at it is the properties of the data center plus the problems exposed by the applications define the software that's going to come out of it. And so I started to test this. And so I don't remember what these slides are for, so let me click the next one. Yes. So if you take a look at this software in these categories, think about when they not necessarily came out or were built, but when they were highly used. That's really the measure of software. It doesn't really matter when software comes out. It matters when it takes off. And a lot of this stuff was very popular around 2006. And the reasoning really is a lot of the software fits the model of 2006. Imagine, for example, Nagios. Adding in Ruby, Nagios is not like a distributed system. It's not a server that you could very quickly add new servers or remove them. It's not very self-healing or any of that. You really have to take care of that server. And that fits within that model. And the model that you don't have elasticity and the model that there's not a lot of cloud usage, it fits really well in there. And it solves problems. And so it's popular. Chef and Puppet the same way. For a long time, they were focused. They've changed a lot. So I don't think I actually talk about Chef and Puppet in the context of today. They're still relevant today. They've changed a lot. But in the context of 2006, they were basically touting divergence correction and really early service discovery. I think every single config management tool's golden example at the time was a load balancer discovering the web servers that it would load balance to. That was the great example, and that's basically gone today. That's not how you do load balancers at all today. And so, but at the time, that's the problems it was solving, and that's what it was built to solve. And they were written in Ruby, which we'll get back to. And deployment, same thing. I don't need to go into that. So then the question really became for me, what happens if I apply that same model to today? What happens if I move it forward and apply the model to today? Will it fit? And can I predict what will happen next? And can I make moves myself, and will they be correct later on? So let's move to today, which I'm going to call the age of the container. It's really the age of C star, where it's container or cloud or cluster or whatever you want to put there. But it's today, 2016. And so we're going to do the same process. So the properties of the data center are never really the unknown. If you think of this as an algebra, that's never going to be X. The properties of the data center are something that are given to us. I guess they're an unknown for the infrastructure providers, but I'm not one, so it's always given to me. So the properties today are everything is API driven, pretty much everything. If you don't have an API today, whether you're at the infrastructure layer or the software as a service layer or platform layer, you're not really adopted. You're not considered serious. So everything has an API. Things are highly elastic. Whether you use that elasticity or not, it's always available to you. So you could add and remove servers really quickly. You could add and remove IOPS really quickly up to a point. You could add network capacity really quickly. If you use a database as a service, for example, you could just scale it up with a click of a button or an API call. Things are very elastic, and a lot of people don't use it. But again, like I said, it's there, and it's a property of everything. There's a lot of small BIMPAC servers. So instead of using one giant server and fitting things on there, there's a lot more smaller servers. People prefer to use, for example, medium-sized or large-sized instances within EC2 rather than double XLs or larger. They're relatively reasonably sized servers. There's containers, and in particular, the way containers are consumed right now are on VMs, and a lot of that is just because all the cloud providers use VMs. That obviously not required, but this is how they're used today, which is an important thing to keep in mind. And then the last thing is it's fast. Then not necessarily the I/O or something you're going to get in the cloud, but the ability to launch things, the speed at which developers are making applications, the speed at which operators are expected to deploy them, whether that's one and the same person or multiple. There's a sense of speed that is expected that there never was before. And if you can't keep up with that speed, you suffer for it. The example I give for the speed thing is last year there was a Jeep recall, and Jeep had to spend, I think, tens of millions, I think it was around 40, I don't remember, but had tens of millions of dollars in order to recall a Jeep, all these Jeeps to patch software. And at the same time, Tesla has a 0 day and they ship over-the-air updates. So relative to Jeep, it's free, and that's all about speed. Tesla used software and used the current properties and available technology to just ship things quickly, remotely to a car. Jeep was stuck using older properties that they haven't moved out of yet, and they've sort of stagnated on, and it costs them a ton of money. Okay, so then let's look at the problems that we're seeing. And these, because it's today, these problems change and they're kind of fluid, but there's some that are really they're problems. So the top one is infrastructure management. So now that we're spinning up and spinning down servers and more things are cloudy, how will we manage all those resources? Before, you would just have an Excel spreadsheet that was your asset manager. You would know how many switches you have. You would look at it and plug it in. And now you have those are software, the servers are software, and they're coming in and out relatively quickly to what was done before. So even if you're not elastic, it's still not on a rolling, few month basis where you're closing tickets and things like that. It's just happening whenever it happens, a lot of times outside of your control. And so the ability to understand the servers themselves rather than the software on the servers is a big problem. So I would say in 2006, I think was the last example I used, 2006, the problem was really what is running on my servers, and the problem today is what are my servers, or where are they? The next one's service discovery. We're using a lot more small things. We're shipping a lot more applications. We now have a genuine problem of how to find things. And as we move towards things like schedulers, which I'll just touch on briefly, things are also automatically moving. So it's not a static IP anymore where you find an application. It's a Schrodinger's cat scenario. It's when you observe it, you know where it is. And when you're not observing it, it could be anywhere. So service discovery is a real problem. Configuration. So configurations is different. We still have a configuration problem, but we're now configuring applications more so than configuring machines. With things like Docker and just microservices in general, it's not about configuring giant software every 30 minutes or an hour, or rarely. It's about deploying these applications and just configuring them when they manifest themselves. Deployment. With smaller servers, a lot more applications, it's just harder to deploy. Before you would hand somebody an application or figure it out yourself, and it's okay if it took a week or 2 weeks or even a few days. It was okay because it was worth it. It would just sit there and run for a long time. And nowadays, people just want things to run. We've seen what Heroku could do. We see what things like Kubernetes could do. We want that for everything. So deployment's a problem. And then the last thing is scale. Just everybody's operating at a lot higher scale, whether it's because the servers are smaller and there's more of them, or you're just getting more traffic, or mobile devices are just bringing a lot more traffic, or new loads of traffic. A lot of companies, the requests per second that were impressive 10 years ago are really amateur today. So everything's just bigger and faster, and we have to deal with that. So then, given this, I would say these problems, I say today 2016, I would say 2014 to 2016, since that's when I started sort of applying this. Then the question becomes, like, what software actually emerges here? And we have some answers now. In 2014, there weren't a lot of answers to fill this in, and I've updated it sort of to fill it in with what's actually happened as well. But the answers, actually, all of these are the same except for the last bullet point. So all of these bullet points I've kept the same since 2014. But my answer was sort of distributed systems. Software has to be distributed systems today. Because things are elastic, most things are elastic, the burden, the mental burden, the work burden of having a handful of things that can't be elastic is the limiting factor. It's sort of, what's that? There's that principle in chemistry where the speed of a reaction is always dictated by the slowest thing, right? And it's the same thing here, which is if you have the one manually managed server, it's just holding you back from everything else you're doing. And so to help get through that, you need distributed systems because they're hard to write, but if you get them right, then they self-heal and they're much easier to reason about, and you could work with them in elastic environments. There needs to be an expectation of failure. Cloud environments just aren't reliable. They aren't. On a day-to-day basis with relatively small scale, you'll see a problem every single day. I think we have customers with tens of thousands of nodes. Us personally, we only have 100 or so. But even at 100 node scale, we see network problems between point-to-point nodes multiple times a day, all the time. And instance failures happen fairly often as well. So software needs to have the expectation of failure. And we see a lot of this with people coming from physical to cloud. They have things that used to be appliances. And a lot of those vendors still provide them as an appliance, but as an AMI or something. And it doesn't work that way unless they've changed the software that's in the AMI, because even if you went to Amazon and said, okay, this AMI is my HSM and it must never ever go down because it's really important, Amazon, they're not going to give you a great SLA on that, as good as you could get in a physical data center. It's just not going to happen. So you need software to expect failure and handle it. API-driven infrastructure as code. Everything needs an API. It doesn't matter what it is. Everything needs an API now because everything needs to be automated. The thing without the API, the thing that's manual, is, like I said, the thing that's going to slow everything else down. So they're going to look for APIs in everything. And And the APIs have to be not painful APIs too. So whether you believe in it or not, it just can't be SOAP anymore. It's not going to be adopted if it's something like SOAP. It really has to be something like JSON over HTTP. We're seeing a lot more things like gRPC and binary protocols that are getting popular, but it has to be a modern, easily consumable API. Low resource usage. This is where Ruby comes in. Low resource usage is now really important because people are shipping things on containers. If you have an agent or you have something that needs to run in the container like Ruby that takes up a majority of the CPU and you're trying to densely pack them on a server, if you're that vendor that's shipping the Ruby thing, you're out. You're just out. And so people are, if you see the shift to Go, you see shift to, Chef just announced their thing written in Rust. A lot of this is for a lot of reasons, but one of those reasons is because we're trying to pack more things on a server, and so it needs to have low resource usage. It's just a requirement for vendors today. And then the last thing is more focus on app deployment. We're moving up the stack, and so the problems even here are less about how to configure a server, and it's really more about how to orchestrate things on top of already configured servers. Like a lot of these problems are assuming that how you set up the server is already solved, which I believe it is. It's really above it that's more difficult. There we go. So today, basically, software design for 2006 doesn't fit very well unchanged in 2016. There has to be changes made. And in a lot of cases, rather than wait for existing vendors, new things pop up and are applicable. And this is why, if you take a look at this thing, I put examples here, there's others, but if you take a look at this thing, other things are popping up because things like the things on the right are just architected more correctly, or they work better in the problems of today faster than the existing software caught up. Yes, so it's pretty crazy. There's so much software that used to be on a server has changed just in 10 years, and it's really tiring. So my disclaimer, though, is that software from 2006 is still highly deployed, highly successful, and highly relevant. It's still used everywhere. I still run into it everywhere. But the main thing is new software, new servers, it's a second-class citizen. It's stuff that's on the way out unless they change. And some software can change. If you look, for example, Puppet's doing their big rewrite in C++, Chef's adapting to things like Rust. They're trying to change in order to adapt to this, and they can. But still, that shouldn't stop people from trying new things, and it shouldn't stop people from trying to build new things because it helps motivate. If Docker never existed, I promise you that all those old things that were crossed out would have been perfectly happy never changing anything and continuing along with the status quo. You really always need an outside agent to mess things up for everybody. But everything's getting messed up for our benefit, eventually. So basically molding our thinking, the way I look at this is you have two choices. You could build out or you could build up. And what I mean by build out is these are new tools. You're not abstracting something new. You're sometimes reinventing something. Or you could build up, which you assume the lower layers are solved, and you build on top of them, and you don't change things. Building up is what we want to do eventually. Building out is sometimes necessary. So it's really both. It's out and up. Sometimes you have to build out, and I argue for containers for these new properties, in a lot of cases we had to build out. But then we start building up as well. Looking at things like platforms. Kubernetes is a good example of building up on top of things. And so in response to Age of Reinvention, when grumpy people talk to me and say, all this stuff was solved for VMs and now we're doing it all again for containers, I disagree, because in the same way that when you have a car and an airplane and a motorcycle and a race car, they all have wheels. They all had to reinvent parts of the wheel for all of them, but they're slightly different wheels. And in the same way, as we sort of move from these things, we have the same problems. The problems didn't change, but we do have to rethink how we're going to build those solutions to adapt to it. And so I'm running low on time here, but if you think of the future, I like to think of it this way, which is what's the data center going to be? What are the problems going to be if it's that data center? And what's the software that's going to emerge? So I'll give you a hint because I don't want to give away how I think about the future. But a hint, like there's two possible futures, not only two, but there are two possible futures for the data center. One is unikernels. Another is this serverless movement. Grown, but there, serverless movement, and there's others. But if you just assume, as much as you might hate the idea of unikernels, as much as you might hate the idea of serverless, your hate is not a good reason not to go through this exercise. So I'm not going to do it here, but if you think, what are the properties of the data center going to be if they're unikernels? Okay, if those problems are solved, what problems are going to emerge? And you start thinking about this, what's my software going to have to look like? And you come up with some interesting things that way. So current generation software will try to mold the future around their own thinking. And it might be right, it might be wrong, but I promise you, no matter what, new tooling that reinvents things will constantly emerge and challenge existing things, and you're just going to have to think about whether build out or up is the right thing. And I obviously have my own opinion. I've shared a lot of them in this talk, and the asterisk here is that I'm heavily biased because I am a vendor, effectively, so consider that, but I've tried to be as unbiased and generic as possible throughout the talk. And just always look to the future and think about what's going to happen. So thank you.